Hello ATM students. This is going to be my first official video lesson, so I hope it goes well. I wrote up some lesson tips for you as you are learning at home. The first tip is to make sure you take notes just like you would in class. Just because it's a video and you can go back and watch it, it means a whole different thing if you're writing it down along with me. You can really take everything to memory. The second tip is to have all your materials with you, including your calculator, especially your graphing calculator today, as we will be using it. Pause the video when you need to. If I'm going too quickly, or if you didn't get everything down and I move on to the next thing, feel free to go back and pause it if you need to. And one of the more important things is any questions that you have on the video, please put in the comment section in Google Classroom. So when I post this video, right exactly in that same post, just go ahead and put your questions in the comment section. Nobody will judge you. It's the better way for you to learn to be able to ask questions, and then I can answer them as best as possible. If you don't feel comfortable putting them in the comment section in Google Classroom, then feel free to email me. All right, so we're gonna go ahead and get started. We are gonna be learning 4-5 today, the class portion. So make sure you title your notes 4-5 class. We are starting on page 517 if you want to follow along in your textbook, the questions and everything. All right, so Unit 3 was all about linear functions, and Unit 4 is guiding us towards exponential functions. So number 1 says, describe the differences between linear and exponential growth based on what we know from earlier in this course. I went ahead and wrote out those descriptions ahead of time so you can go ahead and copy them, and I'll just explain them a little bit. Remember, linear is a line, so it has a constant increase. That increase amount does not change every time you add the same amount to get to the next value. Now, exponential is very different. The growth is a lot faster, so the growth rate between the first and second value is not exactly the same between the second and the third value, because we're not adding this time, we are multiplying the same amount to get to from each value to get to the next value. So as you can see, I underline the important words adding and multiplying. If you're adding the same amount, it's linear. If you're multiplying the same amount, it's exponential. So I also wanted to draw some pictures here. So remember, linear is a line. So, you can draw any line that you want. I'm going to draw a line with a positive slope. So this would be a linear function. And then exponential, there could be exponential growth and there could be exponential decay. I will put a picture of growth, because that's what we're going to be working with in the lesson today. So as you can see, for the linear, it's going up at a constant rate. Exponential, it increases, but it increases slowly at first, and then all of a sudden it very, very quickly starts to increase. All right, so once again, feel free to pause the video if you need to. All right, so moving on to number 2, they give us this table and graph. It talks about winning $15,000 on a game show. What would you do with that money? It said if you were patient enough and you wanted to invest that money, we want to see how much we could make over 40 years. And of course, this would be a fixed rate investment. If you pick a variable rate investment, that means the rate could change over time and you wouldn't be able to necessarily predict it, because it would probably depend on the stock market. So from here, we're given this table, we're given this graph, we can see that the values are increasing. If we did a little bit of math, we can tell it's not increasing by the same amount. Here you can tell that it's, a different amount compared to the first couple amounts. And you can see with the graph, it goes up faster towards the end. So it says for each value in the table after the initial investment, divide the amount by the value of the account the previous year. What do you notice? So I'm going to grab my calculator and I'm going to divide these two values in the table. So I'm going to take 16,000 $50 and divide by 15,000. And that gets me 1.07. Now I can do that for all of them. I'm just going to pick a couple more. I'll do 18,375.65 divided by 17,173.50. And you'll have to round, but you get 1.07. I can do it one more time. We'll maybe pick the last two rows. 24,086.72 divided by 22,510.96. And again, you have to round, but you get 1.07, okay? So what do you notice? We notice that we get the 1.07 each time. So each change is a multiplication of 1.07. Okay, moving on. All right, so number 3, it says, what does your result in question 2 say about the type of growth this account exhibits? So I'm going to put number 2 back up here. Notice I wrote the word multiplication. Each change is a multiplication of 1.07. So because I use multiplication, I can say this is exponential growth. Okay. Number 4, find the relative change in value for each year in the table compared to the previous year. What can you conclude? So it's been a while. I even almost had to double check the formula myself. But relative change is new minus original divided by original. I'm only going to do this one time because it is time consuming and I want to keep the amount of time for the video as low as possible. So I'm just going to do the first 2 rows if you're okay with that. So the new value would be $16,050 minus the original, which was 15,000, and then divided by the original, which is 15,000. So I'm going to go ahead and subtract and divide in my calculator. Make sure you press enter before dividing, and I get 0.07. Now, if you were to do that with all the other rows as well, again, you may have to round, but you would get the same value each year. So this means the value grows because it's positive. It's growing by 7% each year. All right, so number 5 says, find the value of the account after 10 years. Don't multiply 1.07 10 times. That's what exponents are for. So in order to get from this value to this value, we multiply by 1.07. That's what we discovered in number 2, right? We can keep multiplying by 1.07, but if they want us to automatically jump to 10 years, what we can do is take the original amount, and instead of multiplying by 1.07 10 times, we can multiply by 1.07 to the 10th power, and we can use exponents. That's what exponents are for, right? So I can go ahead and put that in the calculator. And I end up with, and again, this is money, so I'm going to put my dollar sign, 29,507. And because it's money, I always round to 2 decimal places to the pennies. So 27 cents. Okay. One thing that I want to notice is you may remember a particular formula that we've used in the past. Depending on the textbook that you're given, it might be different variables, but it's often some sort of A value. Sometimes that's P, and then you would have 1 plus R to the T power. Okay. In fact, I'm going to erase that. I'm pretty sure it's a P for most textbooks. So let's use a P there. And sometimes this is an A, sometimes it's a Y. It really doesn't matter. But that's basically the formula that we're using. The R value that we got is from up here, 0.07. So they're doing 1 plus 0.07. So that's why we have 1.07 here. And then T is time, so we put 10 in for T. P is principal, that's the original amount. So we're technically using that formula even though we didn't realize it. Okay, moving on. Number 6 says use your answer to question 3 to write an equation in the form y equals the expression, where the expression describes the amount of money in the account after X years. Okay, so I'm going to write the formula that we were using, 15,000, and then 1.07, but this time it's to the X power because we don't know the number of years. They just want us to use X. All right, now number 7 says verify that the equation you wrote generates the account values in the table. Ideally, you would either use the table feature on a graphing calculator or spreadsheet. That's what I'm going to do here. So I'm going to go to my y equals in the calculator. I'm going to type 15,000 times 1.07 to the X power. And then I'm going to go to my table. And I'm going to actually pull the chart back up from number 2. Give me a moment to pull that chart back up, just so we can compare. So we'll have to do a little bit of rounding, but we can see that 0, 15,000 is on there. Okay, and then I can go all the way down to 7. And I do have to round. There, my calculator won't do the pennies, but if you round to the nearest whole number, the table that they gave me does match my value in the calculator, $24,087. Okay, so number 7 is wanting us to just verify that, so we can say the values match rounded to the nearest dollar. Okay, moving on. All right, I actually just skipped a pretty significant paragraph in the textbook. I felt like it wasn't really necessary for us to talk about. It's about Excel. So I put at the top to remind myself that I skipped the Excel stuff. They start talking about something that you learned in Algebra 1, actually, function notation. You probably remember it to look like that, f parentheses x, but it's pronounced f of x. It's not multiplication, so they've got that there to make sure you know it's not multiplication. I always tell my Algebra 1 students it's really just a label. It's the same as y equals, but they use f of x equals, okay? So I'm skipping number 8 because that has to do with Excel stuff. Again, I don't feel like it's necessary to go over. It says, for the function describing the value of our $15,000 investment, find f of 12. So I'm pulling up the equation. I think it was from number 7. Let me double check. No, it was from number 6. So my equation from number 6 was this, to the x power. But what they want me to use instead of y is f of x, okay? And then they want me to figure out what is f of 12. So when instead of doing f of x, I do f of 12, that's basically just saying replace the x with the 12. So I now have 15,000 times 1.07 to the 12th power. And then I can go to my calculator and type that in. And again, we're dealing with money, so I will put a $sign. We have $33,782.87. All right. It does say describe what that means. So I'm going to say this is how much money in the account after 12 years. Because remember that exponent is the number of years. It's always the time. Okay, moving on. We're almost finished. I should also mention that I'm skipping the did you get it's. I may have told some of you that in the live meetings that we had yesterday. but I'm going to save the did you get it's for possible skills check or quiz review questions. So, all right, number 10, look back at the graph that illustrates the value of the account. Trace along the graph slowly from left to right and describe what the changing steepness of the graph tells you about how the value is growing. What they're basically saying is start on the left-hand side, take your pencil and start to describe what's happening. So you can see that it's slowly increasing, but over time it increases more quickly. So I'm just going to put over time, the value increases more and more. All right, number 11, how much interest will you earn from 0 to 5 years into the investment? And then it tells you how to mathematically find that. This will be the difference in the value after 5 years and the initial investment. So here's the initial investment. Here's the value after 5 years. It says you could use the formula, but because we're given the table of values, it's a lot faster. We already have those numbers. So all I have to do is subtract those numbers. So I'm going to do 21,038.28 minus 15,000. And I get $6,038.28. So just in the first 5 years, this is how much money the bank gave you for keeping that $15,000 in the bank. It's a lot of money. All right, moving on. This is the last page. How much interest will you earn between years 35 and 40? Now, we don't have a table for these year values, so it says the formula is your only option. So we're going to find f of 35 and f of 40. So I have $15,000, 1.07 to the 35th power. I'm also going to write the next one before I get the calculator back out. 1.07 to the 40th power. Okay, now I'm going to type those in and get my answers to then be able to compare. All right, so after 35 years, wow, we have $160,148.72. I'm just going to edit the 35 and make it a 40. And we have $224,616.87. All right, so it says how much interest will you earn between these 2 years? So after 35 years, this is how much money is in the account. After 40 years, this is how much money is in the account. So then the amount of interest is the difference between these two, just like when we subtracted the difference between these two in the table for number 11, okay? So if I subtract the amounts here, 224,616.87 minus 160,148.72, my interest is $64,468.15, okay? Now, number 13 asks us to discuss the differences between 11 and 12. So I'm going to try to sneak 11 back in here so we can discuss it. So you'll notice number 11 is telling us that, or is asking us to find the amount of interest between 5 years, going from 0 to 5. And it was just over $6,000. But 12 is actually asking us to do the same thing. It's another 5 years, but it's just later. Instead of right away when we open the account, it's much, much later after having opened the account. So notice the difference. In the beginning, we made just over $6,000, but after having the account open for so long, it's still a 5-year difference, but look at how much more money you're making. So number 13 says, describe what you can learn from comparing the answers to questions 11 and 12. Also describe how that fits in with your answer to question 10. Remember 10, we said over time the value increases more and more. So if we're trying to answer number 13, we're basically saying that we can earn a lot more interest over a 5-year period after the money has been invested for a really long time compared to the first 5 years. So let me write that out in a sentence. You can earn a lot more in interest over a 5-year period after the money has been invested for a long time. Compared to the first 5 years. And then I'm not going to write it, but we can say that this does match what we said in question 10, that over time the value of the account increases much more than in the very beginning of the problem. So that is for 5 classwork. Again, if you have any questions, please be sure to submit those in the Google form comment section, or if you're not comfortable with that, feel free to email me. And hope you guys have a good day. Thanks for watching.